help people with some of the more confusing things about isotopes. Isotopes are not that bad, but some people do have trouble with some of the finer things, like writing isotope names and the isotope symbol. All isotopes are, if you aren't familiar, isotopes are just elements that have different numbers of neutrons. So if I look at the periodic table here, and I look at carbon, right? So carbon has 6 protons. Every single carbon in the universe has 6 protons. The number of protons determine what an element is, but some carbons have 5 neutrons, 6 neutrons, 7 neutrons, or 8 neutrons. It's the differing number of neutrons that make isotopes, right? So if one carbon has 5 neutrons and one carbon has 6, we would say those things are both carbon, but they're isotopes of each other. There are some fundamental things we need to be good at when we work with isotopes. One is finding the mass number. So I have over here an equation for the mass number. It's really quite simple. It's just the number of protons an element has added to the number of neutrons. And this is true for every single isotope of every single element. When we write out the isotope name, it's the element name, a dash, and then the mass number. That's all the isotope name is. Isotope names are very convenient when discussing isotopes, because you can talk about any individual isotope with no problem, right? I can say cobalt-60, and if you're good with all this stuff, you know exactly what it means. The isotope symbol is more useful when doing nuclear reactions. We'll see that here later. The isotope symbol has the symbol of the element instead of the element name. It has the mass number in the top left, and it has the atomic number in the bottom left. I color-coded protons and atomic number the same, so that we would know that they're the same. Everywhere where you'll find mass number, it's also color-coded the same as well. So the example on the right here says, write the isotope name and the isotope symbol for cobalt when it has 33 neutrons. So I suppose the first thing we should do is go to the periodic table and find cobalt. So cobalt is right here in between iron and nickel. Its symbol is capital C, lowercase o, and it has 27 protons. All right, so that's super important. If I go back here and I look at my equation for mass number, I'm going to kind of center this on the screen here real quick. My equation for mass number says it's just equal to the protons plus the neutrons. So what's the mass number? I don't know yet, but we did say that cobalt has 27 protons, and based on the problem, I know that cobalt has 33 neutrons. So hopefully, at this point, we can do a little bit of math. We can add 27 and 33 together, and we can get the mass number for this particular isotope of cobalt, and it should be 60. So what do I do next? The next thing I do if I'm trying to write the isotope name is write the element name, a dash, that's not a minus sign, it's not a negative sign, it's just a dash, followed by the mass number. So the element is cobalt, dash, and then the mass number. And I'm going to highlight these so that they're all the same color. I think this color over here was one of these shades of blue, just like that. All right, so there we go. Cobalt-60 is the isotope name for cobalt when it has 33 neutrons. What about the isotope symbol? The isotope symbol has the mass number in the top left, which we said was 60. It has the atomic number in the bottom left, which is 27. That's the number of protons. And then it has the element symbol. CO was the element symbol, and we can verify that on the periodic table if we wanted. 60 is the mass number, and the number of protons is 27. And you know what? Let's go ahead, color code all these things so that they look as they should. And there we go. That's the isotope symbol. Sometimes you've got to work backwards a little bit. So here we have an example that says, how many neutrons does argon-41 have? We're going to need this equation again. So I'm going to copy it. I'm going to put it right here. In this case, we do know some different things. We're told the mass number straight away. So we're told that it's 41. I've got to go to the periodic table, find argon, and I've got to figure out how many protons it's got. Argon's on the right-hand side, third row, and it has 18 protons. Okay. And then I've got to figure out how many neutrons it has. So a little bit of algebra says that we should do 41 minus 18 to get the number of neutrons. All right, so that should be 23. If it's not 23, I'm going to be pretty embarrassed. There's a different method to work back. If we're given the isotope symbol instead of the isotope name, it's still the same process, it's still the same procedure. The mass number is still in the top left. The atomic number is still in the bottom left. We could copy our equation again if we'd like. And you know what, I think I'm going to do that. Let's make the font smaller so that it all fits on one slide here. Okay. So the same thing as before. It's essentially the same thing. Mass number, protons is 3, and then the neutrons ought to be 6, right? So if you're ever curious about how to get the number of neutrons, you can just subtract the mass number and the number of protons together. It always is the number of neutrons. All right, so that's that. Hopefully it provided some people with some assistance here. If you have any more questions, let me know.